Here is my 6th DER and first ISP of my grade 11 year, Project 2.6 Medium ISP Duckman RF Battleship. This project is essentially an extremely basic version of a wireless console, consisting of a small 3x3 LED display, a PS2 joystick, and a basic wireless system. To complete this project, there were 3 main steps, beginning with the PCB design, followed by the code itself, and finally the radio frequency integration in this project. Beginning with my PCB, on screen you can visualize the 3 main stages of my PCB, beginning with my Eagle PCB design, followed by my JLC PCB, and finally my fully soldered PCB. This design process of this board was quite complex, as I wanted to make sure this PCB was not only fairly complex, but also flawless. And despite a few design hiccups, I'm quite happy with the result of this board. The second and arguably most important portion of this project was the coding portion. The specific project consisted of 2 different classes, the transmitter code and the receiver code. The transmitter code reads the joystick values and sends them to the receiver class, where the signals are read and then sent to be displayed on the LED display. To begin, my transmitter code is simplistic, as essentially all that is going on is the values of the joystick and its relative button are being read, then sent over to the receiver code. The receiver code, on the other hand, is a different story, as it is incredibly complex, consisting of a variety of new functions. The 2 main portions of this code remain how the values are displayed and how the ship is hit. For simplicity's sake, let's say that the joystick is on the top left, outputting an x equals 0 and y equals 0. Therefore, both integers row and column equal 0 due to the fact that the map function just downsizes the fraction. Moving on, bit read occurs, using values 1 and 2 outputting a 0. Then the digital write occurs, setting pin 10 low. This process then repeats itself 5 more times, turning each row and column either high or low by following this process. Now, after this process is completed, the following pins are wired high and the following pins are wired low. Therefore, only the top left LED is turned on. This can be seen on the graph on screen. The second major portion of my code is a pair of functions named random x and y, which each do the same thing. Using the random function, a random number is chosen between the values 0 and 2, and pretty much if both of the values match up with the values used earlier, being the output of the map function, the LED and buzzer on the PCB go off, signaling that the battleship was hit. The third major portion for this project was the RF. For this project, I used the Radiohead library and integrated it with 433 MHz transistor and receivers. To simplify an explanation of how RF works, essentially waves are modified through their length by the transmitter to send over 1s or 0s, which translate into messages. This task occurs using ASK, or better known as amplitude shift keying, which essentially forms these waves into 2 different states, the lower amplitude being 0 or a higher amplitude, better known as 1. These waves are then caught by the receiver, in my case the antenna, and then decoded back into letters and numbers. Ultimately, I'm incredibly proud of my first ever ISP, and I'm looking forward to more in the future.